Okay, here's an example of proving an inequality by induction. There are a couple of things I want to say before we start this example. The first is that these can be quite difficult. So I've chosen quite a simple example, and in the worksheets I've also put, or in the worksheet that follows, I've put simple examples because it's easier to get your head around these examples before you tackle harder ones. There are a couple of things that you need to remember when proving inequalities. First of all, that to show or to prove that something's bigger than something else, you would like to show that the difference is positive. Similarly, to show that A is less than B, you would like to show that the difference is negative. You should also remember that inequalities are transitive. So if A is bigger than B and B is bigger than C, that means that A is bigger than C. We'll use both of these thoughts in this proof. Okay, similar start. What happens when n equals 5? Certainly this is true. 2 to the 5 is 32. 5 squared is 25. 32 is bigger than 25. Therefore true, n equals 5. Okay. 2. Assume true, n equals k. That means, i.e., we're assuming that there is some k greater than or equal to 5, for which 2 to the k is bigger than k squared. Prove true for n equals k plus 1, i.e., we want to show that 2 to the k plus 1 is greater than k plus 1 squared if 2 to the k is greater than k squared. So we look at the difference. And we try and relate it back to our assumption, because this is 2 times 2 to the k minus k plus 1 squared, which is bigger than 2k squared minus k plus 1 squared by our assumption. And if we replace the 2 to the k with a k squared, we get a smaller expression. That's what we're assuming. So we work on that. 2k squared minus k plus 1 squared, well, that's just k squared minus 2k minus 1, or k minus 1 squared minus 2. Now don't forget, k is bigger than or equal to 5, so k minus 1 is at least 4, and 4 squared is 16, so this is at least bigger than 14, bigger than 0. So 2k squared minus k plus 1 squared is bigger than 0. That means that our 2 times 2 to the k, which is bigger than this, is bigger than 0. That means that 2 to the k plus 1 minus k plus 1 squared is bigger than 0 if 2 to the k is bigger than k squared. So we've proved yet again that if it's true for n equals k, true n equals k plus 1, we know that it's true for n equals 5, therefore true n equals 6, 7, all n greater than or equal to 5. You may want to watch this video a couple of times before you attempt the exercises that I have put on the worksheet below.